we're going to look at an application of one of the theorems that we saw, or one of the trig identities that we saw yesterday, and that's a question from Cartesian geometry, and how do you find the angle between two lines? Now, you might recall that one of the ways of finding the slope of a line is that it's the tan of the angle that it makes with the positive x-axis. So, line 1 here would have slope of whatever the tan of theta 1 is. Drawing a second line, it would have a slope of whatever theta 2 is, tan of theta 2. The question is, what is the angle between the two lines? Now, I could use a little bit of Euclidean geometry, and that being the exterior angle of a triangle, I know that theta 1 would be alpha plus theta 2. We're trying to find alpha, so if I rearrange that, alpha is theta 1 minus theta 2. But what I now do is find the tan of both sides. But now we have a way on the right hand side of expanding out the tan, which of course goes tan plus tan on 1 minus tan tan. Well, in this case it's the negative one. But we don't actually need to know the angle, because tan of theta 1 we said was slope 1. Tan of theta 2 we said was slope 2. So as long as we know the slopes of the lines, we can find the size of the angle between the two lines. Now, often you'll see it quoted as the acute angle, because obviously there's two different sizes it could be. One will be acute, one will be obtuse, unless of course they're both right angles. And so for that reason, you might see it quoted as the acute angle, but then they put absolute value signs around the fraction, ensuring that that's positive, and so you get tan of alpha as positive, so alpha ends up being an acute angle. So let's do a quick little question here from the 2000 HSC. It's just a straightforward question. Find the angle between these two lines. So we know the slope of the first line will be 2. Slope of the second line will be a third. So tan minus tan, but in this case it's the slopes we're talking about. Slope minus the slope on 1 plus slope. 6 minus 1 on 3 plus 2, which nicely turns out to be just 1. And the tan, that's one of our exact values. Yeah. So alright, we know the angle between those two lines is 45 degrees. Now, 2005, this time they told us the angle is 45 degrees, but we have to find out the slope of this second line. So now I can go, okay, well it's tan of 45 will be 3 minus whatever the slope is over 1 plus 3 times whatever the slope is. Tan 45 is 1, as we just saw. We've got an absolute value equation to solve. I'm just going to multiply both sides by the denominator. So there's going to be two possibilities. Either 1 plus 3m is 3 minus m, or the negative of 1 plus 3m is 3 minus n. So the first one gives me an answer of, we could have a slope of a half. And the second one gives me the possibility we could have a slope of negative 2. So both of those answers would satisfy this problem. So we put down both possibilities. Which one is it? Don't know. They'd need to give us more information to narrow it down to a particular line. So that's just the first little bit. Oh, was that a question or a stretch there? Okay.